You saw from the last presentation, and anybody who didn't just walk in off the street realizes that maps going forward are going to be crowdsourced. I mean, that will be at least a part of the solution. There's really no question about that. I think that's maps are also required. A few years ago, we might have been sitting up here arguing over do we need maps or not. We're really beyond that. What we decided would be really interesting for us to talk about here was, what does that mean, the fact that maps are crowdsourced? We have a representative from TomTom who obviously has some feet in the old making maps through MoMA vans. Is that part of the mix, or is TomTom done and Navtech done? We'll discuss that a little bit. And really try, the other thing I see a lot of is many startups that are sort of sensor makers and mappers. We've seen this with Mobileye. They're moving into the mapping space. How do they fit into this role? Are they a sort of full-service mapping provider, or is there a niche market for them? So those are going to be what we're just going to discuss here today. I'm going to start off by asking everybody to sort of give themselves a quick introduction here, but also they get a question to sort of level the field here. And so the question to you guys is, on a scale of 1 to 10, where are we in being able to build maps to provide support for automated vehicles? And we'll start with you, Peter.
Thank you, Chris. Maybe just a quick introduction. So my name is Pieter Gilhot-Vergouwen, and I'm leading the product management team within the TomTom Maps unit. So to your question, I think my answer is going to be it depends, right? I think if you look at today the scenarios that we're seeing for autonomous driving, I think it's very different whether we look at high road classes, so interstates, highways, and maybe major arterial roads versus destination roads. So it depends really. If you look at highways, I think we're almost ready. I mean, we did some press announcements today where our coverage in the US alone of our autonomous driving mapping components, or road DNA and or HD maps, are now available in 20 states for a total of 22,000 kilometers. So that's substantial, right? So I think that clearly indicates for this kind of autonomous driving scenarios that we are very ready. I would even say that we plan to cover the whole of the US on an interstate level by the end of the year. If you look at local destination roads, however, I think that's a different scenario. I think the complexity there, both from a mapping but also from other autonomous driving technologies, is not yet at the level that we see on the higher road classes. So there I would give it maybe not a 9.5, like I think for the big road classes, a much lower score. Exactly where that is, I think it's difficult to say today.
Okay. Satish, you.
Thanks, Chris. Hi, everyone. My name is Satish Kumar. I lead product management for our OEM customer products at Telnav. So I agree with Peter. I think when it comes to highways and some of the larger arteries, certainly we'll see that a lot earlier than we will see on the smaller roads. I think the key challenge there is, how do you really build out that road network at scale at the HD level in a cost-efficient manner? And we almost need to think about a different approach than the traditional map-making approach that we're used to all these years. The other aspect I would add in, though, also is that the handling of transient and dynamic data that's needed for automated driving is also going to be a key factor. And being able to do that across the board and maintain that data almost on a minute-by-minute basis is going to be a critical piece of the puzzle as well. And that's going to take much longer time to get that across the board.
So you're, again, agreeing sort of at a 9 for major roads, but significantly less for minor roads?
Yeah, I'm not sure what exactly the number I would place, but it's much higher for the highways compared to the rest of the road network, that's for sure.
Lou?
Hi there, my name is Lou Brugman. I am the Senior Vice President of Product Planning and also Project Owner. And one of the many projects that I own, I guess, relatively speaking, includes some of our advanced development with regards to LiDAR. And I had discussed some of this with my team in Japan, and the answer was 6. That's it. No, I'm just joking. So the issue.
Japan is a much smaller country.
So I think the bottom line is 6 is it's better than half. It's a little better, but not quite to 10. And obviously the critical component is that we are working on increment map updates, and we've been doing that since 2006 with our Smart Loop technology, using our own map company in Japan called IPC. And so we have some experience in that. Our hope with the new LiDAR technology and lowering that cost from the $80,000 Velodyne system to even an $8,000 to get somewhere in the sub 100, or maybe $80 system, is that we can put more LiDARs then on more vehicles and provide more true differential map update. And so the key elements that we've been trying to work on is, okay, if we get all that map data and that map updates and try to provide that differential, how do we get that in a compressed format and then get that back out to people? And so that's why we're hedging our bets at the moment. Would give you a 6.
So I mean, we've, you mentioned the crowdsourcing, essentially using LiDAR as a crowdsourced device. Traditionally, I mean, over the years, I've heard companies say getting the data is about 10% of building a map, and this was a navigation map. Most of the work goes into taking all these little maps you collected and making them make sense and incorporating other sensors, other sources of data into that. I think that's overlooked by a lot of people today. So I'd like to, your thoughts on what does it take to build out that map? Is it something that is fairly simple in this modern world? Is it still fairly complex? And traditionally we've had 2 players in that space lately. Is it really something only 2 companies can do, or is this something that any startup, with good algorithms and a few good engineers can tackle? Sudesh, start with you.
Sure. So when it comes to building the maps, from a crowdsourcing perspective, I think we've publicly announced we've been working with OpenStreetMaps. We've got commercial implementations with OEMs based on using probe data. And so it's really a function of how much data you have. There would be errors in the data. There's a lot that we do today in terms of manual quality assurance. But as the amount of data you have increases, you have the ability to essentially reduce the number of hours of manual work put in to fix those maps by using automated technology and algorithms. And as the OEM's fleet start getting more and more connected and we have more cars on the road, we have the ability to do that. For instance, we talked about the speed signs earlier. You may be able to capture a speed sign at one location. You'll get it from 1 car, 2 cars. There may be errors in that for the first few, but if we have 100, 200 of those, of that road segment being traversed, the amount of error in that data becomes less and less. So we have the ability to start automating more of it as well.
Well, I'm going to slightly disagree, being more in the traditional map maker. So I think the complexity today of conflating all those map layers and conflating all that data to a quality level, which a lot of car makers have gotten used to, is to a certain degree being underestimated today, right? I think that's also why a lot of people, you've seen a lot of announcements of people saying we're going to build a map, but we haven't actually seen that many maps being commercialized yet. So I think it's that step from playing with that data and coming to something which resembles a map and coming to something which is commercially viable is a tricky step to make. That said, I'm not saying it cannot be done, but it's not as trivial as many companies think today. Now that being said, I do think as a traditional map maker, we don't have to see ourselves as controlling all the different map layers that will potentially end up in the future in the car. I think we'll see of course, we as a traditional map maker will focus on some of the map layers and some of the core map layers that we've been into for a while and venture into today, like with our HD maps and our road DNA. But at the same time, I think we'll also see map layers that sit on top of these kind of core map layers where, the OEMs, the tier ones and so on will manage some of that data themselves because there's not necessarily a mass market for that particular layer, or maybe that particular data layer is a differentiator for that OEM or for that tier one, so they're not necessarily willing to share that with everybody.
So in a case, if you have a LiDAR sensor, you can make certain map layers with that, probably be very successful in that. Is there going to be a market to take a LiDAR map layer and combine it with a stop sign layer from Mobileye and put that on top of a TomTom map? Is that something where we're going to see much more mixing of those things, or is it?
Yeah. So, and we talked about this maybe even previously a little bit, but definitely the need for some sort of layers or incremental updates is going to be needed. So we've been creating maps probably since our first commercial product in 1990 for GPS on a CD based, and those products are continuous to evolve. This is just kind of another map, but just more data. But it'll have to be, one of the critical components is obviously some sort of compatibility or open SDK that we can actually work together to get that information, so there's this interoperability. So there's going to be many different layers, as we discussed before.
Comments on interoperability?
Well, it's a challenge, right? I think we haven't quite come to terms yet of how the interoperability will work. I mean, there are some implementations where traffic is implemented on top of another navigation map, so it can be done. I don't think we have seen all the mechanisms yet for in this future world of autonomous driving, how all these layers will work together. For some layers, it will be easier because you can do a loose coupling of the layers, right? And an exact road segment matching is maybe not that crucial. For other layers, I think it will be challenging. We'll see if mechanisms like OpenLR and that sort of stuff will be sufficient, or if there will be other technologies needed to do that kind of mapping across.
I mean, one of the questions that we see a lot of is the sort of two strategies for mapping. One is the absolute accuracy, so you base it on a WGS84 coordinate system or whatever, and the other is a sort of a camera-based map where it may be all self-consistent, but maybe 5 meters, 10 meters relative inaccuracy. What does the future look like if we've got a TomTom map and a HERE map, both of which are self-consistent but offset by 10 meters in a world where vehicles are communicating position in some other coordinate system? Is that a viable future? How are we going to deal with that?
Well, first, I'm going to disagree on the 10 meters. Maybe that's of course true for a navigation map where that level of accuracy was never needed. If you look at the HD map kind of accuracies, you're talking at sub-meter level, right? So you're definitely talking about a different level of accuracy in the map data that will be used by autonomous cars. At least for the scenarios where they will use that map data as a complement to their sensor suite. Right? Where that accuracy is needed. They might still, of course, also need a navigation map simply to get from point A to point B, but not have the same kind of accuracy dependency there to function.
So is there an accuracy spec now that for HD maps, both relative and absolute?
An accuracy spec in a sense that there's industry consensus? I don't think so, no. I think that's something which is still in development to a certain degree.
Yeah.
But you have to be realistic that, to be scalable, you're not going to go down to centimeter level, right? So I think that's what we're actively seeing.
But I've certainly seen approaches based on LiDAR cameras that, self-consistent to the 10, 20, 30 centimeter level, but maybe shifted by, meters.
Yeah, possible. I think that depends on the implementation and depends what you do with it.
But,
go ahead.
Well, I would say that brings up another point, though. Even with the LiDAR maps, one of the problems that we've noticed is that self-localization or understanding exactly where the vehicle is to take and acquire that data, whether it's poise or its position, can be critical to feeding back that differential information. So if we're acquiring this data, we need to know where the data exactly came from a perspective, especially at least in the LiDAR case. So this could cause more conflict. But as you stated, I think we're going from meters down to decimeters or even centimeters, hopefully, from an accuracy perspective, more data. Satish.
Yeah, so I agree. I think it's still a reference to a base map, whichever base map you may use. Going back to the layers discussion, I think it's a function of the user experiences that the OEMs want to create as well. It's not necessarily where you need the same set of data or the same level of accuracy for all the data in every use case. And we tend to talk about HD maps and what's coming with automated driving, but we just spoke 10 minutes back about where it's not necessarily quite there yet. And what we are seeing in the marketplace is as connected cars are going to become increasingly prevalent in the next few years, there's certainly an interest in crowdsourcing all those layers of data. Being able to create consistency between the layers is not a new problem. We've had search, POI, address, and other specialized sources of data that are tied into the base maps and the road networks That's a problem we've been dealing with already. It's just that the scale increases. And being able to collect a broader set of data helps you get there a little bit easier. Now, going back to the discussion on what the OEMs would want, it's data that they would potentially collect through their vehicles, and they may want to create those layers. And there are a couple of different approaches from a business model perspective. In some cases, they may want to share their data with each other so as to create scale faster. In other cases, they may want to maintain layers in order to create differentiation. And being able to facilitate, these are not necessarily contradicting to each other, but they could work hand in hand, and being able to support both those models is going to be a key part as we evolve.
Do you see any of those layers as being purchased from a mass or somebody who's not a traditional map maker now, or where do those sort of consensus layers, the layers, probably the base geometry, where do those sort of end that need to be controlled, if you will, by a sort of a master map maker versus these other layers that can be put on by the OEM or by other companies? I mean, are those layers defined yet? Do you have a sense of where the dividing line is?
No, I don't think those layers are defined yet. I think that's also not going to be a static thing, in my opinion, right? I mean, a layer that might be a differentiator today is maybe not a differentiator tomorrow. So maybe it's not worth for the OEM to maintain that layer by himself. Maybe it's easier just to throw that into my more kind of the ecosystem, so to speak, and have the more traditional map maker maintain that layer. So I think it's not a static thing. I think that will be dynamic. Exactly what those layers are, I think is still out there today. I mean, there's some scenarios on like speed layers, for example, right? Behavioral speed data that obviously, a self-driving car of one brand and another brand don't necessarily have to behave in the same way, right? So I think that's one of the scenarios out there where you could have proprietary data that is not shared with the community. The other thing you have to keep in mind as well is, especially as this whole thing builds up over the years to come, is the scale and the volume, right? I mean, as you start rolling out, it's nice to have to think about a proprietary layer, but you still need the scale and the volume of car sensors out there to build a layer that makes sense. So also in the beginning, it's definitely going to make much more sense to pool to pool the different OEMs together, right? To have enough volume in sensor data to be able to build a certain layer. If you don't have enough cars on the roads, it's a nice idea to have a proprietary layer, but it's not going to happen, right?
So, I mean, speaking of combining data from various car companies, obviously that was part of the motivation for the German OEMs to purchase here, to get enough critical mass to move forward and make decisions about what's going on out there. How do you see that playing out over the next year or two? I mean, are you seeing everybody gravitating towards here, in spite of the fact that most of us are probably not seeing that, or how do you think that's going to play out?
You want me to? Okay.
Sure. Got you on the stage here. What's
Yeah.
TomTom's official view on this?
I think it's not just TomTom's official view, right? I think if you look at other ecosystems that are formed, I think it's unlikely that you only have one all-ruling ecosystem. I think that's very unlikely to happen. I think you'll have at least two, potentially multiple ecosystems where OEMs work together and share sensor data to come to certain proprietary or common layers. I think it's highly unlikely that we'll only see one.
Any other comments down there?
So as you look at what's going on in industry, there's quite a bit of interest in making maps. And a key driver for that is maps are becoming more strategic from an automotive industry perspective. Used to be it was one layer in the technology stack powering navigation. Now when you look at the emerging driving experiences and business models, whether it's insurance, energy savings, car hailing, or going on to ADAS and automated driving at scale, map becomes more and more a critical and strategic piece of the puzzle. And ensuring that each of the key players has the ability to control that is going to become a critical piece. And that's why we are seeing more and more OEMs look at what are all the options on the table, including crowdsourcing that data using their own asset, which is the data they can collect from their fleet.
And I think another thing that's driving the open source model is data upgradability or availability to get more refresh or faster data. And that's becoming a critical component to crowdsourcing and providing that. And honestly, from our perspective, we are still working out the business details with regards to how to make sure we commoditize as well. We still need to make money, but also to understand that crowdsourcing is important and that we need that open data. I mean, I think right now that's why we introduced this POC development with here to try to work out some of those details and that compatibility. So.
Yeah, one of the other things I wanted to get to, we've talked about crowdsourcing a little bit, but how do we actually implement that? And especially getting, we're moving towards real-time maps as a part of this. We now have to get the maps out to vehicles, and there's different layers of data that may need to be broadcast to vehicles. Is this a largely solved problem that Sprint or Verizon is going to sort of take care of for us? Or is this still a open problem of how to provision vehicles on the fly with these new high-quality maps?
So this is something we as a connected car and navigation solution provider have been dealing with for years. We essentially work with all the content providers, including the commercial map providers, and create those content layers and deliver that in the car. And we are responsible for the integrity of that data as it's used by applications. So that's the first step. And having those additional layers is just part of that process. As we have other live map platforms feeding in data, it just extends that process as you go. The other critical piece, as we had talked earlier, is the ability to really have that closed loop. So you're building out the maps as you go, some of it real-time layers, some of it probably not that critical. So you don't necessarily have changes in the road that quite that significantly on an ongoing basis on a highway, for instance, but being able to get data around potholes on a much more frequent basis, maybe days or weeks, or around broken down cars by the side of the road almost on a daily basis or hourly basis is critical. So especially as we go towards automated driving. So being able to take these changes, figure out the incremental updates from that map data and deliver that back in the vehicle is a key piece of what needs to be done. This is a piece of technology we call True Delta that we've been working with over for years, and we have a variety of commercial implementations already in the works.
Is that going to be a one-to-one sort of technology? Because obviously, if you could broadcast that data, save a lot on spectrum. Are there ways OEMs can get together to make that more efficient?
Yeah, I mean, the transport mechanism is diverse from what you actually send out. The data that you can send out can be broadcast out based on a specific version of the set of layers that are sent out to the vehicle. At the same time, there's an opportunity to personalize that experience as well. For instance, if I don't leave my city ever, there's only a set of data I need, and being able to optimize for that saves from the bandwidth as well. While someone else who's a traveling salesman is traveling everywhere, probably needs a whole other set of data. And being able to do that just in time based on where I'm actually driving also improves that experience going forward.
And I think to the point about the complexity of the pipe was your, I think your question was, that's one of the things that we're trying to determine. It does require a complete ecosystem. And so whether that's a 5G mesh network or V2V or V2I, et cetera, but the whole structure has to work together, and that drives then that kind of compatibility and making sure that the entire system is ready, because it's not going to be done with just one piece. And I think that's the critical issue that we're facing.
Okay, out there in the audience, we'd like to get to a couple of questions here, so I'm going to run through one more here, but then if anybody can have a question from the audience, we'll be taking those in a couple minutes. So I have, final question to you guys. If there's one problem out there that needs to be solved, do you like somebody in the audience here to solve for us, come up here and give you the answer? What would that be to make the mapping move forward to support automated vehicles? What's the problem these guys need to solve for us?
I think a lot of what we've been talking about implicitly assumes connectivity, and speeding up the process of deploying connected cars out in the marketplace is probably a very good one to start with.
So the sensors are in the cars and so forth. It's really just being
There are
able
some
to...
sensors in the car, and it's going to vary. There's a lot you can extract from probes. Obviously, vision is going to be more and more critical. Collecting that data is important. And then going forward, LiDAR is going to be critical as well. It's going to be a combination of all these, but the first step is how do you have the car connected so that you can start collecting whatever data is possible.
Yeah, to extend on that so it's the connectivity, but also the business models around it, right? I think today the connectivity, your bandwidth of your connectivity. There's a lot of sensors in cars today. We all know these implementations where on your dashboard it shows your speed sign, right, of what the car saw. But all the data still sits in the car. So I think if we can crack something short term, is to make a lot of more of that data available. Both on the inbound side of the closed loop that was mentioned earlier, but also on the outbound side. If you look at in-dash implementations that are being launched today, how many of those have an update frequency which is more frequent than quarterly or even monthly for that matter? I think that's something, there's still a step to make between the concept and actually a lot of these things being implemented actually in the cars. And I think it's not necessarily the technology, it's a lot of the cases also the business model around it. Do we want to pay for that kind of bandwidth?
And presumably we're talking high-value data is going to be over a cellular link and low-value data over DSRC or Wi-Fi or something along those lines.
I'm watching the questions. Yeah, so I mean, to that point on the questions. So basically, I think one of our biggest concerns is interoperability and some sort of set of standards. So if we are going to supply map data to a car that maybe doesn't have our sensors, or vice versa, we're trying to acquire from a car that's using our sensors, but we're trying to send the data to somewhere else, or vice versa. All of these issues, especially at least around with regards to autonomous driving, those standards haven't been worked out, other than and so those open SDKs. And there's good movement, and then obviously the step by step is to figure out, well, then how do you commoditize that, and continue to support. So that's the biggest hurdles that we've seen. Okay.
So we have a few questions here. I guess they both look equally. Okay, I'm going to go to the second one here because it seems to be relevant to this crowd and put some guys on the spot.
I know, that's what I thought it was good.
Okay, so the question is to TomTom and Telenav, would you be willing to share probe data to improve, mutually improve your maps? It's not my fault. Somebody else out there.
Yeah. So I think it depends on the setup, of course, right? I mean, me as a map maker and you as more a system integrator, right? So the setup we have today is when you set up a particular system, right? You come to an agreement whether that probe data is shared or not, right? So in that case, obviously we do share probe data with each other. In that particular setup, right? If Telenav has another deal with, maybe another, God forbid, another map maker and another OEM, right? They are not going to necessarily share that probe data with us, and vice versa, of course, right? So, but we do in that setup. I think we do pass along that probe data. But it's also proprietary, right? So the second part of your question, share it with the public, right? I think it's probe data is sensor data. So we talk a lot about sensor data and new sensor data, but we've been sharing sensor data already for quite a long time. It's also proprietary is the wrong word, but it's also very private, right? Probe data, so it has to be anonymized and it has to be contained. So I don't necessarily see us throwing probe data out there to be shared with the public.
So we certainly have probe data. We've been in the connected and mobile solutions for the last 15 years, so we have our share of probe data. However, we are primarily a technology provider for the automotive industry, and we create technology that enables us to take that data and translate that into map attributes, as well as deliver all the layers of the map data into the vehicle, not into power applications. So that being the primary focus, we're certainly open to different options for where the data comes from. In many cases, when it comes to working with our OEM customers, a big part of what's going to happen is we've certainly seen that across the board where the OEMs are very careful about how they'll handle that data. And just like what we just discussed, the OEMs are particular about privacy and security, and we need to manage those as well. However, it is their data. In many ways, we'll enable them to create their own layers based on their data.
So it sounds like the answer is, you might be willing to share if the relationship made sense and the business model made sense and the OEM said it was okay.
Yeah, and absolutely. And I think the bigger story is what happens when we have a really large fleet of connected cars out there, and what kind of business models are enabled in terms of the different players being willing to share data as well as keep different pieces of it for themselves.
Okay.
maybe just to quickly add, also keep in mind it's never for all of us dealing with probe data, it's never about probe data about just one OEM, right? The strength is exactly today in combining and blending all that data from different OEMs or from different customers, or in TomTom's case, also from our own devices as well, right? Which are still also an important source of our probe data as well. It's in combining that most of the value is.
So that, I mean, it sounds like then you're putting the onus back on the OEMs to make the decision on combining this stuff to some extent.
No, but how do you mean it's combining it? Because we are on the
I mean, you own some of
fusion
it,
end, right?
But I mean, most of it's collected by the OEMs, right? I mean, they would claim, who would have to make that decision to get you guys to share? Is it just going to be between your two companies,
You
or
mean
would it
to
mean,
share it publicly?
Yes, or to share, yeah.
That would definitely be for the OEM's call to do that, right?
So the OEMs would sort of have to step in here and say, we're going to share this for the good of mankind or whatever.
But I don't necessarily see that happen because
Right.
of the private nature of sensor data. I think there were quite a few people on stage here today, making very clear statements about that. That a lot of that data is considered private, so you might be able to use that for certain use cases, but not just to throw out there.
Yeah.
Well, and from a trend perspective, right? Even like Telenav has now got their version with OpenStreetMap, and some other projects. And the previous presenter with Mapbox, his whole company is based upon OpenStreetMap. And the question would be, does the probe data, is that the most important part that's being commoditized, or will that also kind of go the way of an open street philosophy? Because I agree with you that the automotive OEMs are very protective of their probe data. Often they want to own that, and so the question is, but for how long is that really relevant when you have a product like a Waze, which is basically crowdsourced probe data, So it's, anyway, I didn't answer that question, but it was a good comment.
I think it's as good an answer as we're going to get today, because
Yeah.
we're out of time up here. Can we give a round of applause for the panel here? Thank you.